Hello, welcome to the Unity tutorial for my Computer Science 3 final. So, to get started, you're going to want to go on the internet and you're wanting to install Unity Hub. That's the program working right here. And that's basically the kind of main program that holds all your projects, your plugins, your forums. You can communicate with forums, or if you want to use Unity's like tutorial system, you can do that as well. But once you have that loaded up, it's going to ask you to download Unity version. It's going to ask you to download like Microsoft's Visual Code and probably other things that it just needs to install. And you can pick and choose based off of what program that you, or what project or game you want to run. But for me, I have editor version 2022.3.55F1. That's what I've learned to use. You could probably use the newer one. I doubt it would be too much different than what I have currently running, but that is just what I'm using. So once you have everything installed, you're going to want to go to New Project. So I think this is the newer editor, but you can go up here and you can switch it to the 2022 version. And we're going to hit 2D. We're going to do 2D mobile. That's what I'm going to do. And you're going to download template, because that's kind of what I wanted to build the game, was a mobile game. So now you can make a project. Final project, and then wherever you want to store it, Unity organization, that's just my user name for Unity. And if you want to connect this to the cloud, you can do that as well, but I have no need to, so I'm going to select that. So now it's going to create the project, and it will take a few minutes to load all of it. So I will be back when it loads. All right, so now that we're loaded up into the game, okay. So what we're going to start off is you're going to have three tabs up here. You're going to have your scene, your animator, and your game. I'm not going to worry about the animator right now. We're just going to worry about the game and the scene. So the game is basically where you're going to playtest your project. So whenever you click the run button up here or the play button up here, it's going to play, it's going to load, and you're going to go into game view, and it's going to play. You can play your game from this view. The scene view is where you make all your edits. So where you can add backgrounds, you can add characters, enemies, whatever. You can add that all into the scene. And so the first thing you want to do is you want to work on the camera. That's the only thing that you have up in this this little hierarchy tab. So we're going to click that. And you can see it shows this blue screen, which is conveniently the same screen as the game. So the main camera is what you will see while you're in the game tab. So we're going to click on the camera, and we're going to go to background, and we're going to make that solid. I'd say, sorry, solid black. We're going to make that solid black. So now when we go to the game view, it's just a solid black background. And that's exactly what we want for this game. Now what we're going to do is we're going to go to size, and we're going to make it 7. This should be about big enough for the tiles that I want to make for the tower defense game that we're going to be making. I totally forgot. We're going to be making a tower defense game, as that's been what I've been working on the past 2 quarters. So we have our camera. It's at size 7, and that's about it for the camera for now. We can just leave it how it is, like so. So now what we're going to do is we're going to create the actual plots that we can put our enemy, or our, sorry, we're going to put our towers on those plots so they can be placed and then they can shoot the enemies. And it's going to be able to map out our path for our enemies to take as well. So what we're going to do is we're going to go to sample scene and we're going to create a 2D object, sprites, and we're going to make a square. Just like so. Okay. And we're going to keep the scale of 1:1. I'm just going to make this a little, let's make it dark gray like this. And now you can see when you go to the game, you also have that square as such. So we're going to go back to scene, and I'm going to reset the transformation so it's right in the middle of our camera. And what you're going to do is you're going to control, copy, and paste, and you can see it makes a duplicate square. Actually, before you do that, Control Z. We're going to rename it. We're going to name it plot. Okay? And another thing about Unity, what's very nice, is you don't have to keep copying and pasting. And how do you add objects when they're not in the scene? Well, that's what Unity uses. What's called prefabs. So we're going to go into this project. It might be a little differently arranged than I have it here, but you want to go to your project, you want to create a folder and just call it prefabs. Okay, we're going to open it and you're going to drag the plot into this folder and it should highlight as blue. So now that is a prefab that we have. So it's kind of like a blueprint for a plot tile. So now what we can do is even if we delete it, it will still be in this folder. So now whenever we want to use it, we can just drag it onto our scene and it can be removed and we can add it anytime we want. And they are all the same. They'll all be that 1:1 scale, same color. They won't be the same position. You'll have to manipulate that yourself. But now what we can do is we can actually make our map. So now you can copy and paste. And what I'm going to do is I'm going to go to transform and I'm just going to make it, let's say, not -10. We're going to make it -1. I think 1.25 should be good. So now what you can keep doing is you can use, I forgot about this. These help you, it selects what your cursor, how to move it. So like this is rotation, this is scaling, that's scaling as well, kind of everything. Or if you just want to freely move your mouse around. But I'm going to click this crosshair looking shape, and you're going to click Control, and now it will be moving scaled, and just move it across like that. And so now we can copy all these, and we're basically going to fill up our entire screen with these boxes. Just copy and paste and keep a little gap between them. Copy and paste. And you can always just go copy paste. Oh. Like so. I'm just baking our map. It's a little tedious, but trust me, it'll look good. Ooh. When we have it all done. You don't have to add a million, like you don't have to fill up entirely to the ends of the screen. Just about to the ends, I would. Sorry, I had a small problem with my computer. We're good now. So basically you want to fill up your tiles to look something about this. Like it's not completely to the edges, but it's very close enough to the edges. So now what we want to do is we want to make a path for our game, or for our enemies to travel along to reach the end. Because once they reach the end, we'll lose health. So we're going, and this is kind of where you can be creative. You can literally just start in one spot. So I'm going to start here. And you literally can just delete whatever pathway you would want for your enemies to travel. So I'm just gonna be a little creative like that. And it's a little interesting of a shape, but it's pretty nice, you know. So I think it's really nice. But you can make it any way you want. Now that we have all our plots done, we're gonna do one thing, is we're gonna go up to we're gonna just right click on any of them for now. Right click, you're gonna create an empty. So I'm gonna move this outside. So what this does is this can work as like a folder for your objects, is creating an empty object. So like so, it's just game object. Well, you can make it named plots. So now I can select, or I can, now I can go all the way down, select all my plots, and just plop them right in the plots folder. Let me get these ones too. So there we go. Now we don't have to, now we can just tidy it up so it's not all down the hierarchy. So now we have our plots all in one folder. As you can see, when I click it, it will just highlight all the plots. And now what we need to do is we need to map out the area for our enemies to travel. We have deleted it already, but our game doesn't know where this map is. It's not that smart, but it's pretty simple to be able to map these points. What you're going to do is you're going to create another empty. So this is another way it can be used. It can be used, empty object could be used as a folder. It can also be used as points on your game that you want to save. So we're going to call this start point. What we're going to do is we're going to go click this button here, and we're going to select the icon. Let's make it green. So as you see, it pops up as a green icon. So it just allows us to better visualize where this point is. So now what we're going to do, I'm going to reset the transformation, and we're going to go click the crosshair, and again, doing control, you're going to kind of map it to just above your camera line. So this line is your camera. We're going to copy, paste it, and we're going to move it to the end point, and we can rename it end point. And we can make this one red. Oh, red. There. So now we have our starting point and our end point marked. What we can do is we can copy it, again, paste it, and we're going to go to each corner of our track, and we're going to mark points along the track. So copy, paste, and you just want to do it all the way along whatever your track is, like so. Okay, and there you go. You have all your points mapped out like so. And again, we can go and create an empty, and we're gonna name this our path. And so now we can take all of our points, and we can put it in this path empty object and clean up our hierarchy again, like so. All right. So now what we're going to do is we're going to make our first tower, and we're going to make an enemy. So we're going to go to our hierarchy, and we're going to create 2D object, sprites, and we're going to make it let's make it a triangle. So this is going to be our tower, is this triangle. And we're going to move this. Oh, let's move this. Let's move this over. Oh, 1 second. Okay. So, as you can see, it's kind of behind our path or our plot, and that's not what we want. We want the triangle to be on top of the plot. So what we're going to do is we're going to go to the triangle, and each sprite has a sprite renderer, and this just like renders the image of the triangle. And each of them have a sorting layer. And as you can see, we only have one, which is default. Well, what we're going to do is we're going to add a sorting layer, and we're going to call it our towers. And we're going to move it above the default layer. So now you'll see is when we go back to the triangle and we do sorting layer towers. Oh wait, it's not on top. Oh. That is not right. Okay. I'm sorry. I completely made a mistake. My apologies. You want the tower sorting layer to be below the default. Unity is weird where it's not the top will show on the top, it's the bottom one for some reason. So that's why. So now if we go back to our triangle and we do towers, it will now show on top of our plot, just as we wanted it. So now we're going to zoom in and we're going to kind of just like center the triangle on the plot. And I'm going to scale it down a little bit. Let's just say 0.5. Let's do 0.9 by 0.9. Like so. So it's not overlapping the square, but it fits right in it. And we can make the color, let's make it a nice blue. So that is going to be our tower. So we can name it, let's just name it tower. All right, and now we can go to our prefabs and we can drag it down to our prefabs folder and it becomes a blueprint. That's our blueprint, our tower. So now we can delete it and we can insert it anytime we want. All right, now we are going to write our first script of the video. We're going to be writing our first script. So what you want to do is you want to go to your plot prefab and we're going to add a component. And this is going to be a script, new script, and we're going to call it our plot script. Let's just name it plots. We'll do plot manager. And you're going to click create and add. And it should, oh, you might have to wait for it to load. And you're going to click and open it in Visual Studio Code. And here we go. We have our first script in C#. And immediately what you want to do, I'm going to get my reference. Okay. What you're going to do is you can delete these two functions. There's no need for them. As well, if we need to add something like those, we will add them later. So first what we're going to do is we're going to make it so when your mouse hovers over these plots, like so, it will turn white. So it just indicates that you're hovering over one of the plots. So we're going to go to our project, and we're going to make a serialize field. And so basically this what allows us to do is it allows us to take our plot. So we're going to make a private, which means just the script, sprite renderer. So we're basically getting the renderer of the plot image. So like that square, we're going to get the component of that sprite renderer, and we're able to like drag and drop the plot into the it'll make sense when I show you later, but we're going to just make it sprite renderer SR, and we're going to do another serialized field private color. So this is just a color that we're going to change. We're going to change it to white when our mouse hovers over the plot. We're going to make it hover color. All right, now we're going to make some more variables. We're just going to make a private color, and this is going to be our start color. So this is going to be the color that the plot is when we set the. This is going to be the start color of the plot when the game starts. So now we're going to write our first method. Well, not write, but we're going to use our first method, which is the start method. So this is when you run the like when you click play on the game, it will do whatever is in the start method. So what we're simply going to do is we're going to do sr.color. So we're taking the sprite renderer, so the plot, and we're taking its color, and we're going to set it to equal this start color. No, sorry, it's the other way around. We're going to set the start color variable to equal the sr.color. So basically, this means that we can change, if we don't like the gray on our plot, we'll be able to change the color, and it will still store that starting color. We won't have to change any of the code. So now what we're going to do is we're going to write our second method, and it's called onMouse. Oh, not that. It's onMouseEnter. So whenever our cursor enters the box, it will do whatever's in this method. And this is just pre-programmed by Unity. It already has some of these methods already written out for us. So now we're going to make the sr.color, so the plot's color, equal the hover color that we're setting it to. And now we're going to do onMouseExit. Where's the P? There we go. OnMouseExit. So when our cursor exits the box, it will make the SR color, or the color of the plot, equal our starting color. So we'll turn from white back to gray. Okay, so now we're going to click the save button, and we're going to do one thing, is we're going to go to our prefabs, we're going to go to plot, and we're basically going to make a box collider 2D. So this means that our mouse will be able to collide with the object, so it can actually detect our mouse entering the plot. So now we can click play. sorry, forgot to actually sign the plot. So we're going to go to the prefab plot, and you can see it enters right here. And we're going to go to our plot manager. As you can see, it shows an empty sprite render. It says none sprite render. Well, we're going to take the square, and we're just going to literally, or maybe it's take this, and we're going to drag it to our sprite renderer. And now it has our object's sprite render. That's a lot of words to say. But now, when we hover, that's right, we also have to set the color, the hover color, to white. So you can also click this, set it to white, and now, whenever our mouse enters, did I not do that right? Shoot. It should be good. Not sure why it's turning black. It's a little odd. Okay, that was just my bad. When you go to the color, down here it had the opacity at 0, so you want to make it at 1, and as you can see, it now works. So now we can tell what our mouse is hovering over, and we can now start initializing our towers to be placed on our plots. So we're going to go back to our script, our plot manager script, and we're going to make another variable. We're going to make a private game object. So game object is literally, as the title says, or as the word says, it's the game object. You can set a object variable, and we're going to make this our tower object, and this will make sense in a minute. We're going to make another method. It's on mouse down. So when we click on the plot, we're going to want to place a tower object on that plot. So what we're going to do is we're going to do if tower object is not null. So basically this is saying if we already have a tower object initialized, then it's going to return. So it's basically going to not do anything. And this is basically so we don't make duplicate towers on a plot. We just make one tower if we want one. All right. So now if it passes that and there is no tower, we're going to do tower object equals instantiate. I think that's how you say it. It's going to be we're going to we're gonna make another serialized field. I'm sorry. And we're going to make this a private game object. And this is going to be our tower prefab. And so we're going to put the tower prefab that we had made earlier into that serialized field. Now we can go to tower prefab. And this is going to create an object. It's going to basically take our blueprint and we're going to make it an actual object. And we're going to put it on the scene. So as you can see, it's game object. Then we're going to do transform. So we're basically saying where we want this object. Transform.position. So we're going to make it the transform of the script game object. So it's going to do the transform of the specific plot square. And the position, so like the X and Y and Z axis of that plot square. And then we're going to do quaternion.identity. Now this is basically just rotation. So the rotation is exactly oriented with the plot object. This would make more sense in like a 3D game, but we still have to do it in 2D because you could still like rotate stuff in 2D. It's a little odd, but there we go. We have created our tower object, and that's it. Now we will click save, and you'll see, oh, that's my, we go back. We're going to go to plot. We're going to go to our plot manager. We're going to click and drag the game object tower in the tower prefab. All right, let's test out and see if it works. So now when we go and click, and you can see towers are being placed on our plots, just like so. Now, obviously, we would want to have like a currency system, but we can do that in the future. So we're going to click close. And one thing I'd want is you want to reset this transform and do 0.9, 0.9. Because as you saw, it was kind of up on the plot a little bit. It still is. Not sure. It's a little odd why. I'm gonna make it, just make it like minus 0.5 or 0.05. Sorry, this is just, okay. I don't know. It's just gonna be like that for now. All right, now what we're gonna do is we're gonna make our first enemy. So we're going to make these circles. So we're going to go to sprite, 2D object, and then circle. And we can make this a bright, let's do a maroonish, amber, not really amber, but red. Kind of like blood red. And we're going to make it our enemy. Like so. So we're going to go to, we're going to reset the transformation. And I just want to, I think that would actually work. I don't think it's too big. No, that will work just fine. And we're going to drag this to our prefabs like so and delete. And so what we're going to do is we're now going to code our spawning system. Okay. So this is where it's going to get a little bit complicated with the coding, but if you follow along, it should be fine. So we're going to add component. We're going to add a script. And this is going to be our enemy spawner script. Let's just call it enemy spawner. Create and add. We're going to let it load. And then we're going to double click. And now we have another blank script. So first what we're going to do is we're going to do public static enemy spawner main. So this is going to be used for when we call this script in other scripts. It can just go enemy spawner.main and then we'll be able to use any of the methods in the enemy spawner. So this is just for, because there's only going to be one enemy spawner, if that makes sense. So we're going to do we're going to do a serialized field, and we're going to make a private game object, and this is going to be our enemy prefab. So this is going to be our enemy object that we're going to call later. So we're going to make a serialized field, and this is going to be our private int, and we're going to make this base enemies. So this is going to be how many enemies do we start off on the first wave. So we're going to do 8. So start off on first wave. We're going to do another serialized field, private float. So float is like a double for Java. you just rather use float. I don't know exactly why. It's just something with the program that just likes floats better than doubles. So we're going to do enemies per second equals 0.5. So it's going to spawn enemies, or 2 enemies per second. So it's just in the name, 2 enemies per second. We're going to do another serialized field, private float time between waves. And this could be 5F. And you got to add F for the end of float. So F for float. And this is going to be, so once we've killed all of the enemies, it's going to wait 5 seconds to start spawning the other one, or the next wave. So you kind of have like a little bit of downtime in between the waves. So, downtime between waves. We're going to have serialized field, private float. This is going to be our difficulty scaling factor, and this is going to be 1.5F. And so basically, we're going to be using our difficulty on an exponential scale. So every wave is going to get exponentially harder, but it's going to be slowly harder. It's only a 0.5 scale. Just so, waves don't get boring after playing the same one, as you continue the game, it's going to get very, very hard, at least in theory. So exponentially getting harder. And then the last serialized field is going to be a private float, enemies per second cap. This is going to be at 10F. And, I forgot my bracket. And the reason we have this is so you're not spawning, and I might not even make it 10. I'm going to make it 5. So you're not spawning 100 enemies per second, because that's just a lot of that's just a lot of performance that takes a real hit on your computer. So we're only going to cap it at 5. But it could mean that there be more enemies. It just doesn't spawn them as quickly. So as some private, some variables, we're going to make a private int current wave, and this is going to be 1. So we're always going to start on wave 1. Private float time, if I could spell, float time since last spawn. So this is going to be used, so we can track how many enemies per second. It works with the enemies per second. So works with enemies per second. We're gonna make a private int enemies alive. And this is just tracking how many enemies we have alive so we can know when the end of a wave is. We're gonna have private int enemies left to spawn, and this is just the name. How many enemies do we have to spawn left per wave? Make a private float enemies per second. I don't know why there's 2, but I made 2. I don't know, that's a little weird. I'll probably figure out why there's 2 enemies per second, but there is. And then we have a public, we're going to do a public bool is spawning. And so in my actual game, I probably used is spawning in a different script. I don't know if we will for this tutorial, but we'll just put it there for now. And so we're going to start making our methods now. This one being the awake method. So this awake is basically whenever you use the script. So whenever an object is entering the scene, it will do the following script, or do the following things in the method. It's not the same as a start, because start is at the beginning of the program, while awake is like the beginning of it's like a character, when like a character is born. I guess I don't, if that makes sense. So basically, when we call on, it could be calling on the script, it will run this method. So we're just going to do main equals this. So we're basically saying that this main variable that we had up here is this script. That's pretty much what it is. So now we're going to do private void. We're just going to do a start method. And we're going to keep this for a little bit later. And we're going to do another one called update. Now, update is in Java, usually it updates automatically all the time. Well, in C#, it will only update what's in these. This is kind of like the main method for Java, is this update. And so this is kind of like your main for Java. So we're going to do some coding. So if is or isn't or not is spawning, we're going to return. So basically, if it isn't spawning, or how do I say this? If it isn't spawning, it's not going to update because there's no there is no, wait, what? Let me see. Okay, so if it is spawning, it's going to return. So if there is still enemies to spawn, it's not going to, or it might be the other way around. If we'll just see. I don't know how to explain it because is spawning is false. It's going to be true when there's enemies spawning. So it's false when enemies are spawning, I guess. Sure. Oh, no. It would be the other way around. If they aren't spawning, it would be true. Okay. You get the gist. Okay. I should not waste your time. All right. So we're going to do time since last spawn, our variable. We're going to plus equal time dot delta time. So this is basically adding up time. So taking a time function, delta time is, I think your computer, based off your computer's time or your phone's time, something like that. So it's going to add up seconds to this time since last spawn. And now we're going to do if time since last spawn is greater than or equal to 1f divided by EPS, and if I can find the and enemies left to spawn is greater than 0. So basically what this is saying is if the time since last spawn is greater than our enemies per second over 1, so it's just a calculation for if it's like if it's 0.5 enemies per second, or if it's 1 enemy per second, 1 over 1 is going to be 1. So if the time is 1 second, is over 1 second, then it's going to spawn another enemy. And if there's still enemies left to spawn, it's going to spawn it. But if there's no enemies left to spawn, then it's not going to spawn enemies. So we're going to have a method. Okay, so what we're going to do is we're going to write a spawn. We're going to write a spawn enemy method. So whenever it meets the right criteria to spawn an enemy, it will actually spawn that enemy. So let's write that. We're going to get out of the update method and we're going to make a private void spawn enemy method. And so basically we are going to get our enemy prefab, and we're going to initialize it like we did with our tower, and we're going to have it just initialize, and it's going to start at our starting point. So this is how we'll write it. We're going to do game, or we're going to get, we're just going to instantiate enemy prefab at the, we'll need to write the start position. So I'm just gonna do start point quaternary quaternon dot identity, and we're gonna make this start point position. We can do that by getting our serialized field, private game object, start point. So we're going to get the start point, and we're going to do dot position, or dot transform dot position. So it's going to get the game object, the start point, and it's going to get the position of that start point. So that's what's going to happen when we spawn the enemy. All right, so now every time we spawn an enemy, we're going to want to decrease our enemies left to spawn. So it knows that how many enemies to keep spawning, and we're going to do enemies alive plus plus because we just added another enemy. And now we're going to have time since last spawn to equal to 0 because we had just spawned an enemy. All right, so now for the final part of the update method, we're going to do if enemies alive equals 0 and enemies left to spawn is equal to 0. Let me spell this right. We are going to have an end wave. We're going to have an end wave function. So basically, whenever there is no enemies left on the map and there's no more enemies to spawn, it's going to end the wave. So let's write that. We're going to have private void end wave. All right. And so what we're going to do is we're going to turn off the is spawning because we're no longer going to be spawning any more enemies. We're going to have time since last spawn equal to 0, as we have likely just spawned our last enemy. And so it no longer spawns any more enemies. We're going to set the time set to last spawn equal to 0. We're going to do current wave plus plus to indicate that we're going to the next wave. And then we're going to run a start wave method. So we're going to write that really quick. And now this one's going to be a little bit different, as it's going to be a different type of method. It's going to be a private IE numerator start wave. And so what an IE numerator is it's just another type of method, kind of like void and public. It gives a return of IE numerator, but what I usually use it for Unity is for when I want to wait a few seconds before I want to run the stuff in the method. It kind of adds a wait function. So I'll demonstrate that now. If we do yield return new wait for seconds, we can do time between waves. And so basically, when we run the start wave, it's going to wait the 5 seconds that we have in between the waves, and then it will run the method to start the new wave. So it kind of acts as like a wait. I think Python has like a wait method. It basically kind of acts like that. So we're going to write the rest of the method. So after the 5 seconds, we're going to turn on is spawning equals to true. We're going to have enemies left to spawn. We're gonna leave that blank for now, but we're gonna have another method that's enemies per wave, and it's gonna calculate using our difficulty scaling how many enemies we should have to spawn, and then our EPS is going to be another method called enemies per second. And again, that also is going to use our difficulty scaling factor to increase the amount of enemies per second. So let's write those two. We're going to have private int enemies per, oh, if I spelled right, enemies per wave. All right, well, if I can type correctly. Oh. And so basically we're going to return, we're going to do math f, so math float dot round to int, because we're returning an int. We're going to do our base enemies times math f dot pow, so power function, our current wave, and then our difficulty scaling factor. So basically, it's going to take the power of our current wave and take it to the power of the difficulty scaling factor and times it by our base enemies to increase the amount of enemies that we will return. And that's how many enemies that will spawn for that wave. And now we're basically going to do the same thing for enemies per second. We're going to do a private float because that's what our EPS variable is stored in. Enemies per second. I must not have. Oh, let me put a. There we go. We're going to return again math f dot clamp now because we are going to. We're going to give a maximum, which is our enemies per second cap, and we're going to have our minimum. So we don't go over that max, and we don't go under that minimum. So our enemies, and you can see, it says it right there, your float value, and then your minimum and your maximum. So we're going to have our enemies per second, our base enemies per, if I write it right, enemies per second times math f.pow. We're going to do our current wave, again, times the difficulty factor. And now we're going to set our minimum to be 0 because we don't want negative enemies per second. That wouldn't make any sense. And then our maximum is going to be enemies per second, and then our cap. All right. And now that should be, let's go back to our end wave, and we're going to run the start wave. Now with IE enumerators, you're going to have to do a start coroutine and then start wave. It's just like another way to run a function, but it's going to basically start the method at that point. Okay, let me make sure. That should be it for now. So we're going to save, and we're going to go back to our game. And we're going to want to make a, we're going to want to make a empty object called level manager. And this is just going to be an empty game object because I had originally set it to the enemy, but we don't want the enemy to spawn itself. So we're going to remove component, and we're going to put it on this level manager, because it's a main. We had put that main at the beginning, so we don't want it to be on every object. We just want it to be on one. So our enemy prefab, we're going to put right there. And then our start point, we're going to get to our path and go to start point. All right. So the last thing we're going to code for now, for the enemy, is we're going to make the enemy movement script. So we're going to code it to find each point and move to those points on the path, like so. So let's do that. We're going to go to the enemy, add component, new script, and we'll call it enemy movement. And wait for that to load. All right. So let's start. We're going to do a serialized field, if I can put it in the brackets. And we're going to make this a private. We're going to need the actual body of the enemy, because we're gonna, in the future, we're going to get we're gonna need it basically allows you to change the velocity of the body. It kind of is like physics, so we need to change the physics of the enemy. We can't just change the position, because that would be kind of it would take a lot of computing power, which would be too much for a bunch of enemies. So we're gonna do a rigid body 2D. Just name it RB. Then we're gonna do a serialized field private float, and we're gonna move our move speed. So basically we can change the move speed if we want to during testing. And then we're going to do serialized field private. We don't need to. I have that in my game for future, but we do not need that. All right, so we're going to do a private transform target. So basically this is going to be the point that the target is going to. So our it's going to update the target as it passes through each of the waypoints that we have on our map. Then we're going to do private path index, because we're going to be putting all of these points, these path points, on a this should be an int path index. We're going to be putting all these points on a array, so we can add that. So we can go through the path index array. All right, and that reminds me, we're going to do a serialized field private game object, and this is how you do arrays in C#. You just do game object, and then you do the bracket, and then we'll do path. And so what we can do is we go to our script, we go to our enemy movement, our path, and what we can do is we can go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So we're going to need 15 for my map, but it might be different for yours if you decide to, whatever you decide to do. Let me go back to scene. Okay, so we need 15 elements, so basically be 14 elements technically, because that's how arrays work. And basically you'll just need to these not game objects. What? Hold on. Let me add all the points, and I'll get back with you. Okay, I just figure out the problem, and it's mainly just based off of what Unity's kind of how do I say it? It's the how Unity like recognizes objects. So basically, I can't add you can't add objects from the hierarchy into a prefabs script. So what we're gonna have to do, and it's a simple fix, we're going to have to take this path right here, and we're gonna move it to our enemy spawner. And as you can see, if we save it, we can now go to level manager, and we have our path, and now we can add our points. So I will be doing that, and so just add all your points, and it will create a whole map for you. Okay, there we go. I have all my points. As you can see, they're all right there. It'll pop up. But make sure to add your end point as well. So let's go back. We're going to go to our enemy movement. And now what we can do is we can do, we can continue along with our movement. And so what we're going to do is at the start, we're going to make a start method. At the start, we want our target to be the level manager, or sorry, not level manager, enemy spawner dot main, and then we're gonna get. Let me make sure this is yes. This needs to be public because we're gonna be accessing it from our enemy movement dot path, and then we're gonna do our path index, which is going to be 0. I forgot to set the value. So now it's going to do, our target is going to automatically be the first point in our map. Okay, so now we're going to go to our update method. So as for every frame, so if we're going to get to physics, so vector 2, because we're a 2D game, dot distance, we're going to do our target point, so our point on the map, dot position, and then our transform, so our current enemy object dot position is less than or equal to 1.0f. So basically, like really close. We're going to increase the path index because we're basically right on that point, so we want to now start heading towards the next one. So we're going to do path index plus. If the path index is equal to our enemy spawner dot main dot path dot length, so basically if we've already hit the end of the path, we want to now we're going to write an enemy spawner dot main dot on I'm sorry, we want to dot main dot enemy destroyed. One second, let me make sure I'm writing this right. Okay, so we're going to make an enemy destroyed method in the enemy spawner. Let's make that right now. We're gonna do a public void enemy destroyed, and basically this is going to make the enemies alive minus. Make sure that is right. Yeah. So we're just gonna enemies alive minus, and then we're going to get the game object. So our current, the enemy that's the script's going to be attached to, and then we're going to just do can dot destroy. Where is it? Oh, yeah, that's right. Sorry, it's a method. Destroy game object. There we go. So, and that's it. So it's basically gonna delete our enemy once it's hit the end point because we no longer need the enemy. Okay, and now we're going to just return because that's going to be end of the update for the current enemy. And if it hasn't hit the end, then we're going to make our target equal the enemy spawner dot main dot path, and then our path index. So it's basically going to select the next path point on our path. Okay, next we're going to do private void fixed update. Now, I'm not exactly sure what fixed update is. It's just another update. It's like it updates at specific points. I'm not exactly sure when it does it. I haven't really looked into it very much. But fixed update, we're going to do vector to direction. So it's going to pick the direction of our enemy is going to equal to the target dot position minus the transform dot position dot normalized. And so I don't know exactly. I'm not too familiar with it, as I'm not much into the Unity physics yet. But I think it's taking the position of our next waypoint minus the position of our enemy, and normalized. It's a vector from, looks like 1 is the same direction. So it looks like it's getting the direction of that point. That's what I'm assuming. So what we're going to do is now we're going to take our rigid body dot velocity. So we're about to change the velocity of our enemy to equal the direction times the movement speed. So now it's going to move into the direction of our point times the movement speed that we had set. And that's about it. That's it for our enemy movement. So what we can do is now we can actually test our game out. At least in theory, test the game out. In about 5 seconds, it should start spawning enemies if everything's going accordingly. And this, oh yeah, you can use debug to be able to look at all of the variables. Looks like something is not right. Let me see. That's right. I completely forgot. We have to start our start wave at the beginning of the start function for our enemy spawner, because it's not going to start a wave if we don't initialize that. So that's my bad. And now it should work as intended, at least in theory. Again, things can go wrong, but it should give us about 5 seconds. And what is that? That is right. I need to add the rigid body. So we're gonna first add the component rigid body 2D to our enemy, and then we're gonna scroll that to right there. There we go. I'm sorry, forgot about that. But add the rigid 2D body. You're gonna bring it over to the enemy movement, and now we should have movement and hopefully enemies going through the path. There we go. We have an enemy, and it is moving through each path, just like so. And you can see in the scene it moving to each point, and then it's moving. Boom, 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 boom. And you'll see when it comes to this end point, it is going to delete itself. Delete, delete, and yeah, they're going to keep deleting. All right, so now that we have our enemies done, all we need to do is make our tower shoot, and then we will be done with this tutorial. I know it's been a little long, but we are on the home stretch, and then we will have an actual tower defense game. So what we're going to do, we're going to go over to our tower, and we're going to create a new component, a new script, and we're just going to call it our tower script. All right, let it compile, and we're going to open it right up, tower script. All right, and now we'll get to coding. We will start with some serialized fields. We're going to get our private transform. If I can spell. What we're going to do is we're going to get a tower rotation point. And so basically we're going to get a point at the middle of the triangle that we have, and it's going to rotate the tower around that point to rotate towards the enemy, so it fires at the enemies and follows the enemies and tracks them. Next, we're going to do a serialized field private layer mask. Now I will show you what that is in a second. It's going to be our enemy mask. Okay, we're going to get a serialized field private game object, our bullet prefab. So now let me show you what the layer mask and the bullet prefab is. So what we're going to do is I'm going to go to our enemy, and this layer, we're going to add a layer, and it's going to be, we can make it, we need to, let me see. It needs to be, can I add a element? Maybe not. Let's see. Oh, I'm in debug, that's why. Okay, hold on. Let's go to our enemy. Make sure you're out of debug, go back to normal. Add layer. And we go to user layer 6, and we're going to make it an enemy. So basically, it's going to detect objects that are inside the enemy layer. So it's not detecting, our tower's not detecting our path or our waypoints or nothing else, or other towers. We just want to rotate towards enemy objects that are in this enemy layer. So we're going to go to our enemy, and it's going to go to our enemy layer. And now what we're going to do is we're going to create a 2D object, physics circle, and we're going to make it, we'll make it a yellow. And we're going to make it very small, just about, we'll do 0.2 by 0.2. Yeah. And this circle is going to be our bullet. And, oh, sorry. And it's going to put it into the prefab so we can add it to our bullet prefab. So that's what we're going to shoot out of the tower, is those bullets. All right. Next, we are going to get serialized field private game object, transform. And this is going to be our firing point. So wherever the bullet is going to come out of the tower, likely the tip of the triangle. We're going to use serialized field private game object tower object. So this is just literally going to be the tower. And then that should be it for the serialized fields. No, it's not. We're gonna do serialized field public float targeting range. Targeting range is going to equal 5f. So this is basically how far our tower can target enemies. It's going to be like a circle, and it's going to have a radius of 5. We're going to do a serialized field public or private. And I don't think it needs to be public. That can be a private. I have it public in my actual script, but I don't think we'll need to make it public for now. We're going to do private float rotation speed. Oh, I did not mean to take a screenshot. That's my bad. Misclick. Rotation speed is going to equal our 200 float. It just is really fast rotation speed. It's going to how fast our tower rotates towards the enemy. Serialized field private float bullets per second. And we're going to make that 1. So every second we're going to fire 1 bullet. Let's do 0.5. So we do it 2 bullets per second. That would be 0.5. Let me do 2 bullets per second. Serialized field private. That should be it for the serialized fields. Okay. We're going to do a private transform target. So basically the enemy that we are going to be targeting. We're going to do a private float time until fire. So again, we're going to have the seconds between we've fired so we can detect the bullets per second, kind of like how we did with the enemies per second. And that should be about it for that. So we're not going to have any start method. We're just going to have an update method. So we are going to do if we have a target equals to null. So basically if we have no target, then we're going to find, we're going to do a method called find target and then return. So let's do that method. Let's write it. So we're going to do a private void find target, and we're going to do ray cast hit 2D. So basically it's going to cast a circle with a certain radius that we're going to mark, and we're going to make an array with all of our hits. So basically all the enemies that are in our tower's range. So we're going to do physics 2D dot circle cast all. Circle cast all, and we're going to do our transform dot public because we have to do our origin, and then our dot position. Then we're doing our float radius, so our targeting range, and our vector to direction. So we're going to cast it to vector to transform dot position. That our distance is going to be 0f, and then our mask is going to be enemy mask. So our distance, you might think, is not right, but since we did the targeting range, that is our radius. Our distance is kind of like the, I think, distance from the our origin point. So like if there's like a zone where we don't want, but we don't need to worry about that. All right. So, if hits.length is greater than 0, so basically if we have an enemy that we have hit, we're going to have that target equal hits 0.transform. So basically we're going to get the first enemy that our tower detects, and we're going to set that to our target. All right, so now that we have found our target, we are going to, so if we have a target, we are going to rotate towards target. And now we need to write that method as well, which is pretty, it's not that simple, but it's not that much code. Private void. And you could not make these methods, but I like to tidy it up and make methods for all these. So rotate towards target. We're going to make our float angle. So we need the angle that we rotate to is going to be math f dot atan, so a tangent 2D target dot position for our y, and our dot y. So we need the y part of our position minus our transform dot position dot y, and then we need to do the same thing with our x. Okay, and that is our position. So that got our angle, and now we need to times it by our, we need to do math dot rad, so radians to degree, because what we just got is radians, so we need to change it into degrees. So math radian to degrees minus 90, because I'm not really sure why we minus 90, but I did. I can't remember exactly. All right, so now we need our rotation. So remember quaternon neon, that is for rotation. So we're going to do target rotation equals quaternon neon dot Euler new vector 3, because rotation is in 3 vectors. We do 0f, 0f, because we don't need to rotate x and y. We just need to rotate z angle that we just calculated. All right, turret, or we need a tower rotation point dot rotation is equal to quaternon dot rotate towards turret, or a tower rotational point dot rotation target rotation speed times time dot delta time. Okay, that was a mouthful, but basically we're going to turn our tower's rotation at this rotation point that we set, that we're going to set. We're going to rotate towards, we're going to start from, as you can see, we start from our tower rotation, this rotation, and then we're rotating to the target rotation that we need to rotate to, and then the max degrees per second is what delta is. So like the change in max degrees is going to rotate at the rotation speed times our delta time, or our change in time. Okay, that was a lot, but we have the, so we'll start rotating towards our target. All right, now we need to check if our target is in range. So check target is in range. So we're going to have to write that method too. This is a lot of method writing. But this is a really simple one. We're gonna write it here. Private bool check target is in range. And so we're just gonna return vector2 dot distance. We're going to take the distance of our target position, and then our transform. We're going to take the distance from our transform. So our tower is less than or equal to targeting range. So basically we do this so if in between we find the target and we run the check, if it's out of range, then it won't fire if it's out of range, basically. So if it returns true, then or if it returns false, then we're going to do target equals null. Then else, we are going to do, so if it is in range, we're going to do our time until fire is plus equal to time dot delta time. And then, so we're going to increase the times per second. Yes, times per second. And then if that time until fire is greater than or equal to 1f, so basically our bullets per second. So basically, if it goes to the time where we need to fire, it will shoot, and we'll write the shoot method, and then our time until fire will equal 0f. All right, our shoot is a little bit complicated, but it's the last method we should need to write. So private void shoot. So we're going to do our game object, a bullet object equals instantiate. So we're instantiating our bullet prefab that we had created at our firing point dot position, and then the rotation is just the identity of the bullet prefab that we had made. And now we are going to create a bullet script for our bullet to kind of home onto our enemy, because the bullet's dumb. We have to create the physics for our bullet. So, unfortunately, we have one more script to write. Maybe not unfortunately, it's been a long video, and I'm sorry if this is way too long, but I kind of wanted to go into the deep and dirty into the code. So let's go back to our game, and we're going to go to the bullet, and we're going to make a new script called bullet. We're just going to call it bullet. Hold on. My bad. Let me do bullet script. Okay, looks like that worked. I guess I can't make it the name. That's my bad. So we're going to get bullet script. All right. What we're going to do is we're just going to quickly serialize field a rigid body 2D, RB, and we're going to have to serialize field private float bullet speed equals 20f. We're going to serialize field private int bullet. We're not going to do bullet damage, because you could if you wanted to upgrade your tower's damage, but for this tutorial, we're not going to worry about damage. If a bullet hits an enemy, it's going to kill it. That's what we're going to do. So we're going to do private transform target. So basically the target of the bullet, and then we need the private game object tower shooting. So we're going to get the tower that is shooting the bullet. All right. So we're going to do public void set target. And we're going to set the target of the bullet. We're going to do transform. So inside the, we're going to require a transform of the target, of the enemy target. So our target is going to equal our target underscore. So basically the bullet is going to be targeting whatever the tower is targeting. So we're going to do a private void fixed update. So only updating when the bullet is active. So if we do not have a target, we are going to return because there's no point in doing any of this if there's no target. We're going to start coroutine, and we're going to have a bullet death. And so basically this is going to avoid where if the bullet is just flying off the screen because the enemy was already dead, then we're going to just kill the bullet after about 5 seconds or so. So we'll write that in a second, but we're going to do a vector to direction equals your target dot position minus transform dot position, and then dot normalized again to make the direction the bullet is traveling. And we're going to make the rb.velocity equals direction times bullet speed. So it kind of copies what we did for the enemy. All right. We have about we actually don't need tower shooting. We can get rid of that. We have about 2 more methods we need to write, and then we are completely done with our game. So we're going to do private void on collision enter 2D. So basically whenever we collide with the when we ever collide with the enemy, we are going to destroy our game object, because once we hit the enemy, we want to destroy it. All right. And then we want to do private, i.e. enumerator, our bullet death, which we had up in the fixed update. Basically, just yield return new, wait 4 seconds, and we're gonna do 3 seconds. So after 3 seconds, the bullet's gonna die no matter what, in case it goes off screen. That's just so we don't have a bullet flying forever and ever if it misses our enemy. It would help if I spelt start coroutine right. There we go. Okay, so we're going to go back to our tower script, and we're going to finish up the tower. So once it shoots, we're going to get our bullet object, and we're going to have our bullet script. Bullet script equals our bullet object dot get component. So we're going to get the component of the bullet prefab, which is the script called bullet script. And so now we're going to do our bullet script dot set target. We're going to set the target to be the enemy. We're going to do the bullet script dot set. No, we're not going to set tower. That's it. We just have to set the target of the bullet. And then that should be everything completed. We're going to do one more thing. I lied. And this is just so we can see the targeting range of our tower if we wanted to. We're going to do private void on draw gizmos selected. It's going to, we're going to do handles.color equal color.blue I'm going to make a blue circle handles dot draw wire disk transform dot position transform dot forward targeting range. And so basically we're going to do the center, which is our transform, our position. The direction is forward, and we want the radius to be our targeting range. So this should be it. We're just going to now assign the rigid body. So we're going to create a rigid body 2D for the bullet and assign it to the bullet script. We're going to go to our tower, and we're going to double click the tower, and we're going to create, to create our rotation point. So we're going to create our 2D object, or is it empty? Yes, it's empty. Let me make it an empty 2D object, like so, and it's going to be right. You can see where the object is. You want to make it right in the center. It should already be centered when you create it. Then our firing point, we want to, let's make this our rotation point. And then our firing point is going to be another empty object, firing point, and we want to move this point up to the tip of our triangle, like so. It's like at the front. Here's our rotation point in the center. Oh, sorry. Let's make it about there for the center. And then that should be it. We can go back to our scene, go to our tower. We'll actually double click it again. We go to our rotation point. We're going to click and drag the rotation point. Our bullet prefab is going to be from down here. Our firing point, we can click to there. And our tower object, we can just go to tower and tower object. And one thing I'm going to do, I'm going to change the bullets per second to 1, just so it's not like super easy, the game. But anyhow, we should have a game all completed. Let's click, and there will be our tower, and we will see if it will rotate towards, it does not rotate towards, hold on. All right, one thing you're going to do is you're going to go to your bullet, and you're going to create a new layer, and you're going to put an enemy bullet layer, and you're going to have a circle collider 2D. Okay, so basically what I had missed is that you want to add a circle collider 2D to your enemy. Because the sprite is a circle, that's how it will, it has to collide like that, when it does the raycast hit 2D, it has to detect the enemy object, and it does that by using that circle collider. And then make sure you have a circle collider for your bullet, and that should be good. And also, when you go to the tower, double click it, you want to copy the sprite render. You'll do copy, and you'll do remove, and you want to orientate. You want to have your tower, you want to have your rotation point, then you want to make another game object named tower, and you want to put it inside the parent rotation point, and you want to put the parent, or the game object firing point, into the rotation point. Then you go to your tower, and you can right click transform, you do paste, and then component as new, and it will paste your sprite render on the triangle. And so now, as you see, when we play the game and we put our triangle in, you will see that it rotates and fires at the enemies. But one thing that I forgot to do is I forgot to program to kill the enemy. So what we're going to do is we're going to go to the enemy movement. We're going to make a public void destroy enemy. Okay. And so what we're going to do is in the method, it's going to be destroy game object. Or, game object. All right. So the bullet is going to collide with the enemy, and then we're going to call enemy movement dot. We're going to do collision dot game object dot get component enemy movement. Okay, and then we're going to dot. It's going to be dot destroy enemy. So basically what we did is we got our collision, the body. So the collision 2D is what we collided with, and we're going to get the game object, so the enemy's game object. And we're going to get, if I pull it up, we're going to get, so this is the game object right here, and we're going to get the component of the enemy movement script right here. Okay. And then we're going to use the method destroy enemy, which is going to kill our enemy once the bullet hits. So I'm also going to make this 0.5 bullets per second, just so it's a little bit slower firing. And now if we go to our game, we can click on our tower. You'll see when the enemies come, it will kill the enemy when we fire at it. And now what you can do is you can add scripts that will add health. You can make upgrades. But one more thing I want to do is I want to display our HP or our health, and I want to display our wave number. So this is what you're going to use. We're going to use Unity's kind of UI system. So what we're going to do is we're going to go to our hierarchy. We're going to kick the right click, go to UI, and then we're going to do canvas. And we'll just call it canvas. So as you see, it's going to make this really big box on our scene. And what we're going to do is we're going to go over here and we're going to change this to scale with screen size. Okay. Expand. Screen match mode expand. So basically, this is going to match our screen size. So our screen isn't like for bigger phones or like a computer, it's not going to shrink it down, or it's not going to ruin the UI, if that makes sense. And we can also do that with our main camera. You can probably code some way for all this to be scalable. I haven't done that myself, but what we can do is we can go to canvas, right click on it, and we're going to go to UI, text message pro, and you might get these two pop-ups. You're just going to put import, and it's going to import, and we're going to now have text on our screen. Close out these, and as you can see, when we go in the game, it has new text right here. So we're just going to slide it over here as such. We're going to call this our health. All right. Then what we can do is we can go to new text. Let's just say HP, and then we'll say 100. All right. Like so. Let's make the fonts. We can make it about 24 or so, just like that. All right. And then we can do right click again, go to UI, text, and we can make this one our wave, a wave number, which will be on wave 0 to start, or wave 1 to start off with. Wave. Okay, then we can make this 24 as well. Bring it over to here, and we'll just line it up like that. And I want to make it, we'll make it centered, and we'll make this one centered too, like that. So we go our game. Let's edit it just a little bit. Make it to the side. There we go. Wave and HP. And obviously you could make it a lot prettier than this, but for tutorial sake, we will keep it like that. So last thing is what I want to do is we want to go to our enemy movement to edit we want to go to the enemy movement script. And what we're going to do is we're going to make a serialized field, private game object, or we're going to make it a text tmprepro text I forgot the name. Let me check. It's basically we're gonna import and we're gonna get the text, so we can manipulate the text from our script, and that is going to be, that's right, it's gonna be text mesh pro UGUI, and then we'll just make this our HP. And so what we can do is when our enemy goes to the end right here of our path, what we can do is we can go hp.text equals HP, and then we can go to, let's make a private, we'll make it, an int health equals 100, and we can set, we can do hp.text equals HP, and then plus our health. We can do the same thing right down here, just copy, paste. We'll do health minus, we'll just say 5. We'll do, put parentheses, health minus 5. So basically it's going to take our health and we're going to deduct 5, and then we'll do health. Actually, it'd probably be better if we just did health equals health minus 5, like so, and then we'll display the new health. All right. And now we can go to our enemy spawner, and we can do the same thing. Serialized field, private, text mesh pro UGUI, and we'll make this wave num. Okay, and then we'll go to we already have our current wave, so at the start we'll do wave num equals wave plus, and then current wave. Oh yeah, you have to do dot text, and then we can do, when we end a wave and we increase the wave, we can paste it right there. So now, as you'll see, we can go to our game, and I have to actually reference. That would probably help if we can get our canvas, our health, or our wave. We can just slide it there. Then we can go to our enemy, and we might have to, this might not actually work. No. Okay. What we're gonna do is we're gonna go That makes sense. So we're going to go to our enemy movement, and we're going to copy this, and we're going to put it into our enemy spawner. Because again, the way Unity gets their objects, it has to be inside the object, I guess, for it to be able to if it's a prefab, it has to be inside the game object, otherwise it won't work. I'm not sure exactly why, but what we can do is we can literally set this to public, and all we have to do is go back to the enemy movement. We can delete this now, and we just got to do enemy spawner dot main dot hp dot text, because I think that's what it is. Yep. So hb.text, and we copy and we paste it. Oh, paste it like that. And so that's a little, like, you know, working out bugs, and that will happen all the time, obviously, when coding. Now we should be able to go, once we integrate the health. Now this should work, and we'll see. I won't place any towers down, and you can see it has updated, but we'll watch as the enemies go by. And here we go, coming to the end. They'll reach the end, and they're deducting our HP. Looks like it's only doing it once, which that's a little odd. Why is it only doing it once? That's right, because we have health equaling 100. We actually need, we're gonna make this, we're again gonna put our health in public health, public int health, because it's making, every time basically every enemy was making the health 100, and we don't want that. We want it to be a universal number. So again, we can go to enemy spawner dot main dot hp or dot health. Is it public? Oh, I need to save it. Should be public. Oh, I just misspelled it. Okay. Again, copy and paste. We'll do just copy, boom, and it might just offer you suggestions, but just copy and paste it. Now it should work. And again, this is a lot more complicated than I have it in my game, because I have a whole level manager script, but I felt like it was too much for this simple tutorial. Well, it's not really a simple tutorial, but let me actually do it without having a tower, because so you can demonstrate the HP going down. So as you can see, the health, well, there we go. It now goes down by 5, not just sticking at 95. And I have no game over screen because I have not actually added that to my own game. But as you can see, the wave has increased. And with that, I think that this is a successful game, at least starting out. There's obviously a lot more that you could do, and I have done with my game. For example, I'll bring over my game that I have made. And you could see I have a lot more things, if it would load. Yeah, just taking a bit. Another thing, you can have a simulator. So if you want to simulate an iPad, but I just keep it on the computer. But as you can see, I have multiple different enemies, and I have 2 types of towers. I have a basic tower, and then I have a freezing tower that will freeze, like so. I actually, this is my home computer, so I don't have it, but I do have upgrades for the ice tower, but it does not show up because I forgot to import from school. That's wrong. That this would be one of the upgrades, but don't mind that. It kind of doesn't work because my home version isn't up to date with the current version of the game. But you know, so they have upgrades for both. They have upgrades for both the ice tower and the main basic tower. And I also have another menu for my factories that I have added. They're not done yet, but I could always show you that at my school computer, and I'll probably import it later. But I think that's about it for the tutorial. It's probably way too long than it needs to be. But that is it so far. That's all I've learned. Those are the basic principles that I've learned using Unity with these 2 semesters. And yeah, so thank you for watching. If you have watched all this way, I had fun remaking my game, but this version is pretty simple. It's simpler than my own, and this video would probably be a lot longer if I directly made a copy of my current game, because it has a lot more stuff into it. But I hope this demonstrated everything that I've learned, and hopefully you know Unity a little bit more now that you have watched it. So thank you for watching, and goodbye.